In the previous lecture, we studied about the equation of the simple harmonic motion, and now we discuss about the nature of the simple harmonic motion. First of all, we find time period of the simple particle performing simple harmonic motion. The time period for the simple harmonic motion is the time in which particle repeats its motion, so that the particle completes one round about the fixed point. We have already discussed that the equation of motion of the particle performing simple harmonic motion is x is equal to b cos k under root t. We know that the period of the cosine function is 2 pi. So cos theta is equal to cos theta plus 2 pi. There is no change to add 2 pi in this equation in the cosine function. So we add 2 pi and take k under root common and dividing inside by k under root, and the equation x is equal to b cos k under root t plus 2 pi over k under root. From these two equations, we see that the particle is at the same position at time t and at time t plus 2 pi over k under root, so that the particle after this time is at the same position in the same direction, moving with the same velocity at time t. So the particle has repeated its motion during this time interval t plus 2 pi over k under root minus t, that is 2 pi over k under root. This is the time period of the particle performing simple harmonic motion. Frequency, the number of oscillations in 1 second is called frequency. The frequency is reciprocal of time period. We can directly find the frequency from the formula for time period. Frequency is reciprocal of time period, gives us the formula k under root divided by 2 pi. Center of motion. The fixed point O on the path of the particle is called center of motion. Maximum velocity. We know that the velocity of the particle in the simple harmonic motion is v is equal to k b square minus x square under root. Students know that we have already proved this one, that v is equal to k into b square minus x square under root. So now we find the maximum velocity. To see the maximum velocity, we observe the behavior of the particle during the motion. Suppose the particle is initially at point A and it moves to the fixed point O. The velocity increases from A to O. When the particle reaches at the point O, it does not stop due to inertia, but it goes to the point A dash. The velocity decreases and the particle retreats to the fixed point O, and then it goes to the point A. Thus it completes one-way round. So the one-way round, the time taken is time period. When the particle moves from A to O and then from O to A dash and then comes back from A dash to O and from O to A, it reached from the point A and completed one round, then the time taken is time period. The number of oscillations in 1 second is frequency. The center fixed point is the center of motion, and this is the velocity. Now we see what is maximum velocity. For the maximum velocity, we see that the velocity increases at the center, so that when x is equal to 0 at center point O, x is equal to 0, the velocity is maximum. So we put x is equal to 0 here, and the maximum velocity is v is equal to under root k b. Now we see maximum acceleration. The acceleration is a is equal to minus kx. This is definition of the simple harmonic motion. The acceleration a is equal to minus kx. This is by definition a is equal to minus kx, and the magnitude of the acceleration, this is magnitude of the acceleration, negative sign finish. The acceleration is proportional to the displacement x. Maximum x greater, more values of x, then more values of the acceleration by definition. The maximum value of x is b, the extreme value from the fixed point O to the one end of the path. X is equal to suppose b, so maximum displacement from the center is b, x is equal to b, and we put here x is equal to b, so maximum acceleration is also a is equal to kb. So we must know about these notions of the simple harmonic motion, the time period of the particle performing simple harmonic motion is 2 pi over k under root, frequency is k under root over 2 pi, center of motion is O, maximum velocity is k under root b, and maximum acceleration is a is equal to kb. Now we discuss about another important physical problem related to initial value problems, the motion of projectile. What is projectile? An object thrown at some angle to the horizontal is called projectile. For example, an object thrown from an aeroplane or a stone thrown by hand. These are the examples of projectile. The trajectory of projectile, the trajectory or path. A particle of mass m is thrown at an angle alpha to the horizontal with initial velocity v naught is equal to v naught cos alpha I plus v naught sin alpha j. Let the particle is at point p x y. Moving with velocity v, the position vector is r is equal to xi plus yj. We now obtain derivative. First derivative dr over dt is equal to dx over dti plus dy over dtj. The only force acting on the projectile during its path is the force of gravitation. F is equal to minus mgj. Negative sign is due to that the force is downward, so the force is minus mg. The particle is thrown upward and the force acting is downward, so there is negative sign, and we know from the Newton's second law that the force m is equal to d square r over dt square. So we replace f by m is equal to d square r over dt square. Now we divide both sides by m, and m is finished, so we get d square r over dt square is equal to minus gj, and the second derivative of the position vector, this one becomes this d square x over dt square I plus d square y over dt square j is equal to minus gj. Now we equal the I component on both sides and j components on both sides. D square x over dt square is equal to 0, d square y over dt square is equal to minus g. Now these are two second order differential equations. This equation is in x and this equation is in y. We integrate respectively both of these equations. First of all, we integrate this equation. When we integrate this equation, on the left hand side we have dx over dt. On the right hand side, the integral of 0 is equal to a. Now we integrate this equation. Left hand side, the second derivative is finished, and the first derivative dy over dt is equal to minus gt plus b. In these equations, we have constants of integration. In this equation, the constant of integration is a, and in this equation, the constant of integration is b. We have to find these unknown constants, and we need initial condition. The initial condition is that at time t is equal to 0, the velocity is equal to v naught. V naught is equal to the particle is thrown in the plane at some angle alpha. So the components of the velocity at initial time t is equal to 0 becomes v naught cos alpha I plus v naught sin alpha j. So we put these equations, dx over dt plus dy over dt j is equal to v naught cos alpha I plus v naught sin alpha j in the velocity, and we obtain v naught cos alpha is equal to a and v naught sin alpha is equal to 0 plus b. So a is equal to v naught cos alpha I and b is equal to v naught sin alpha, and we put these constants here, the value of a and the value of b. When we put value of a, dx over dt is equal to v naught cos alpha, and value of v naught sin alpha, dy over dt is equal to minus gt plus v naught sin alpha. Again, we integrate these equations. The left hand, these are two equations, and now these are first order differential equations. Again, we integrate this equation and this equation respectively. First of all, we integrate this equation. The left hand side gives us x, and the right hand side integral of v naught cos alpha dt. This equation we integrate y is equal to v naught sin alpha integral dt minus g t dt. V naught sin alpha t minus g t square by 2 plus d. Now again, here two constants for this equation. The constant of integration is suppose c, and for this equation the constant of integration is suppose d. These two unknown constants are to be determined, and at time t is equal to 0, the particle was at the origin of the plane. I suppose x is equal to 0 and y is equal to 0. When x is equal to 0, at time t is equal to 0 for this equation, time t is equal to 0, this term will finish, and x is equal to 0, this will finish. This is 0, this is 0, so c is equal to 0. And here, when time t is equal to 0, y is equal to 0. Y is equal to 0, the left hand side becomes 0. On the right hand side, when t is equal to 0, first term finishes. When t is equal to 0, second term finishes. So d is equal to 0. So x is equal to v naught cos alpha t, y is equal to v naught sin alpha t minus half gt square. These are parametric equations of trajectory of projectile. These are parametric equations in terms of t. We want to obtain Cartesian equation. We take the value of t from here, divide x is equal, divide this equation v naught cos alpha, we get the value of t. T is equal to x divided by v naught cos alpha, and put this value in the equation of y. In this equation, put the value of t from here, and we get t, value of t x over v naught cos alpha, value of t in square, x over v naught cos alpha square. This is x. First x, v naught is cancelled with v naught, remaining is sin alpha divided by cos alpha minus 1 by 2 v naught square g x square cos square alpha. Open this for this square term, and again y is equal to x sin alpha divided by cos alpha is tan alpha minus 1 by 2 v naught square g x square cos square 1 by cos square alpha is secant square alpha. This is the equation of parabola. So the path of the projectile is parabola. Now we discuss about the time of flight. These are parametric equations of the trajectory of projectile. We obtained here the parametric equations. Now we use these equations to find the time of flight. The time of flight is time taken by the projectile in reaching the final point. When the particle reaches to the ground, at the final point, the particle projectile reaches to the ground, then height component y is equal to 0. When y is equal to 0, right hand side is also equal to 0. From here we cancel one t from here and t from here is cancelled, so we are remaining with v naught sin alpha minus half gt, and we get v naught sin alpha is equal to half gt. Multiply by 2 to finish this 2. We multiply the equation by 2 and get 2 v naught sin alpha is equal to gt, and from here we divide by g to get t is equal to 2 v naught sin alpha divided by g. This is the time of flight. The time of flight is simply obtained from the parametric equations and put the y component is equal to 0. When the y is equal to 0, the particle comes to ground and it has completed its flight. So the time taken by the particle to complete its flight or to reach its final point, then y is equal to 0 and we obtain time. Horizontal range. The distance traveled along the distance traveled along the horizontal is defined as the horizontal velocity multiplied by time of flight. As distance formula, by the distance formula, the distance is equal to velocity into time. In the case of range, horizontal velocity, horizontal range, the horizontal velocity multiplied by time of flight. The horizontal velocity is v naught cos alpha and the time of flight is 2 v naught sin alpha over g. So we simplify this one. This is a very simple formula for distance, and the values we have obtained here we will put here horizontal velocity and time of flight, and we simplify to v naught square v naught into v naught square sin alpha cosine alpha divided by g, v naught square into 2 sin alpha cos alpha, 2 sin alpha cos alpha, that is sin 2 alpha. So v naught square over g sin 2 alpha. This is the horizontal range. This range, maximum range, we know that the horizontal range is equal to v naught square sin 2 alpha over g. Here we see that v naught is constant, g is constant. Range, horizontal range is maximum when sin 2 alpha is maximum. And we know that the maximum value of sin 2 alpha is 1. Sin 2 alpha is equal to 1, then the angle 2 alpha is 90 degree and alpha is equal to 45 degree dividing by 2. So sin 2 alpha is equal to 1. The range is maximum. Sin 2 alpha is equal to 1, then angle is 45. So when a particle, an object is projected, is thrown at an angle 45, it will get maximum horizontal range at and its value, range maximum, is equal to V naught square over G. Some main points here are this one, the equation, parametric equations of the trajectory, and the Cartesian equation, that is in parabolic form, and time of flight, that is 2 V naught sin alpha divided by G, and the horizontal range V naught square sin 2 alpha over G, and maximum horizontal range, that is V naught square over G.